And we are live. Welcome to today's episode. Today we're diving into Scientific's VLDB accepted paper on multilingual guardrails, where AI, privacy, and low resource languages come together in one very powerful story. Joining us today are two of the minds behind this project. Dr. Abhishek Mukherjee, Scientific's field CTO, is an award-winning AI leader with over 18 years of experience building real-world AI solutions for Fortune 100 companies. From shaping Gen AI strategy to holding 40 plus patents and publications, he's done it all. And we also have Scientific's AI lead, Harshit Raj Gadia, who led the development of the lean annotation process that powers this research. He is an AI leader and a great part of the team. Let's jump in and explore how this team built smarter, safer AI without ever touching real personal data. Dr. Abhishek, Harshit, welcome to the program.
Thanks, David.
Thanks, David.
Dr. Abhishek, my first question is to you. You know, there's been a lot of emphasis on responsible AI. And my question to you is, what is Scientific doing in this space?
Absolutely, David. Responsible AI is a very important factor in being able to productionize AI solutions. The key here is the LLM is behaving responsibly, or any kind of AI solutions are behaving responsibly and not giving answers which would actually harm the receiver or help somebody to harm somebody else, right? For example, if by accident somebody is giving an input which reveals their PII information, like social security number or address or phone number and so on, right? So even if by mistake a person is able to is giving it, the LLM should be responsible enough to not be including that into the output, or basically even being able to process it, right? So that is how we can make the LLMs or the solutions that are using LLMs responsible. So this work actually contributes towards that. I would actually hand over to Harshit to explain in more detail what exactly we did in this project.
Yeah. Thanks, Abhishek, for the introduction. So as Abhishek rightly said, as LLMs are growing, they have to be responsible. So we see a lot of use cases where a PI redaction system has to be developed and improved over time. So to do this, we actually built a human-in-the-loop system where we curated 40,000 plus prompts across a variety of low-resource languages. And here we are using a lean annotation framework where we can produce such prompts with PII embedded in it.
And you know, Harshit and Dr. Abhishek, in one of our previous conversations, you mentioned that knowing how clients plan to use the data really helped shape your annotation strategy. Can you give an example?
So what's important here is to actually understand the LLM vendors like the Mag 7s, right? They want to actually improve their LLMs such that they're able to detect these PIIs and then act on it, right? Such that they will be able to build a responsible AI strategy on their own, right? So what we try to do here is they're coming to us for the data, and the annotation and the data that we are providing them is actually at a very fast speed. Essentially, within a few weeks, we are able to generate the data for them. We are able to validate that the data matches some certain quality standards, and we are able to also help the annotators do this work fast. So this is what we call lean annotation process, and we are able to develop this across the board for multiple of these work streams that we help our customers with. So that's what we are developing.
And Harshit, do you have anything to add to how you chose this annotation strategy?
Yeah, so basically, we chose this annotation strategy with a basic ethos that we are actually complementing the humans. We are making them more intelligent during the annotation process, so they can make better informed decision, which overall increases the quality and decreases the handling time.
And in your project, the average handling time was one of the key metrics that you used to measure this process. And this paper that you wrote, where you have documented your process and you recorded your results, was actually selected as a conference paper for VLDB happening in September in London. Congratulations, by the way.
Thank you.
Thanks.
Now, my next question is, can you tell us a little bit how you chose this topic? And Dr. Abhishek, if you could.
Yeah, so this was also part of our strategy to be able to actually cater to responsible AI. And one of the aspects was essentially PIIs be included, right? So this is like providing training data which has PIIs, and the training data here is a prompt. So we were authoring prompts in these low resource languages with our on the annotation platform and with our native crowd, as well as the FTEs who are expert linguists, language engineers, and so on, right? So the work here entailed being able to help these annotators with a variety of automations that we put together. Harshit can actually give you more details on the automations, but overall, right, this was a work where we were providing these authored prompts, right? We were also marking these prompts as labeled data with the PIIs that were in the prompts, and then also the responses that were generated by the LLM, right? Whether the responses contain those PIIs or more other PIIs, we were even marking those such that the LLM input as well as the output is a labeled data, which then is fed into like a fine tuning solution. And then eventually the fine tuned or the trained LLM will be able to detect these PIIs, and appropriate action can be taken, right? I mean, during the inference time, it can then choose not to actually process those PIIs, and it can choose not to provide any information back to the user. I mean, all the information that is put back to the user actually is minus the PIIs. So that is the overall idea here. Harshit, would you like to add to this?
That totally sums it up. Yeah.
Yeah. And Harsha, LLMs nowadays, they know English really well because there's a lot of available data in English. But what about other languages across the globe that there may not be so much data?
Yeah, that's a very good question. So as we know that the coverage of English in training LLMs is far more than when we say pick a low resource language, let's say Vietnamese. Okay, so if you see the coverage of the low resource language, it's very skewed, and as we can see that nowadays in the responsible AI era, the support for this low resource language has been growing faster than ever. So, so there is a big demand to train intelligent, responsible AI LLMs in this low resource languages as well. So, and that becomes a core motivation for this paper is to not focus on the languages which already have a good coverage in their training priors, but rather than focus on languages which are very skewed in the training pipelines.
So not only is your challenge was to use low resource locales, but also the challenge was to use over 300 plus PIIs and different combinations. And, you know, as I understand it, the task was to generate prompt content that contains combinations of PIIs from a list of over 300 across these low resource locales. How did you go about solving this complex problem?
Yeah, that's a great question again. So here, basically, we're trying to solve a chicken and an egg problem. To as Abhishek mentioned, that to develop such PII reduction systems, we need to embed the PIIs, and we need to embed in such a way that it's not an actual PI because it goes against the GDPR rules. So here, the task is to embed PIIs which are synthetic but real looking. So to do that, we leveraged a combination of regular expressions and Python libraries like Faker and Mimesis to generate synthetic real looking PIIs. Now, how it works is they have they have built-in data providers which holds the rules and templates. For example, if we were to initialize this, let's say for a Vietnamese language, and we select a name from this built-in provider, so this module will be able to generate Vietnamese sounding names. And it also has custom data providers. Suppose if there is a PI which is not supported through this framework, we can generate rules so that whatever PIs which are generated through this are in line with that specific locale. For example, let's say talking example of SSN for a US country. So it will have rules like it should have 10 digits separated by 2 dashes in between. So that's how we developed this synthetic PI generator module. Two things which I want to highlight here is it takes a lot of time for a annotator in the loop to do this manually. So this helps a lot in decreasing the handling time. And second, to maintain diversity, we have put a module such that whenever we recommend a specific PII of a specific locale to an annotator, it gets freeze. It doesn't get recommended to another annotator. So this way, we are enabling the diversity when we are suggesting the synthetic PII in the annotation process.
So you mentioned something very key, that you're able to maintain diversity, but what often is the case, if you try to maintain diversity, it increases time and you lose scalability there. But you're able to maintain scalability even by creating lots of diversity. And you used LLMs as a judge to do that. And I thought that was very innovative. I really like this idea of using an LLM as a judge. Usually humans check AI's work, but here AI is also checking humans. Can you tell me how actually that works in your system?
Yeah, sure. So as the topic is for diversity, so that is the key element of the data distribution. So the task here is to create some 40,000 plus prompts spread across low resource languages, but it's not like they have a uniform distribution. It's distributed across many layers. For example, what task category should the prompt belong to? What domain should the prompt belong to? What should be the word count one need to follow? What is the language again one need to adhere to? So all this are, we can say, instructions to the annotator which they need to follow while crafting the prompts for training. Now, what happens is, since this is a very this needs to be developed in a very short time, and the number of tasks is so much, annotators often fail to abide to some instructions while crafting such prompts. This actually leads to a lot of back and forth between annotator and the reviewer, decreasing the overall quality and increasing the handling time. So that's why we developed an LLM-powered instruction following module, which can check such metadata instructions which annotator should adhere to. So what happens is, while crafting the prompts, they can really check whether all the key instructions are being followed or not. And if not, LLM also gives a rationale why they think it's not followed. So here they can make a better informed decision right there, rather than coming back to the loop through a reviewer.
I think this is really key, and I want to emphasize this again. A lot of the fear out there is that AI is going to replace humans. But I think in your system, humans and AI are working together to check each other's work, which creates this feedback loop that amounts to more scalability, better diversity, and more data types. I thought that was very interesting. And I think that from your work, you can see that it can be very effective and very scalable.
Yep, exactly. So we have scaled this to a couple of low resource languages, and we have enabled these features to a big group of annotators without having any major latency issues. So all this processes, which are like AI enhancement, falls under the bucket of lean annotation, which has been scaled to not to an experimental pipeline, but to an actual real world use case.
Wow. And this system that you've created is called the lean annotation process, correct?
Yes.
And this system that you've put in actually developed some interesting results. Can you walk us through this graphic and tell us how the lean annotation process actually helped?
Yes. So basically, the lean annotation process is again the human plus AI framework, where humans can make better informed decision through AI enablement. So in our experimentation, we developed two groups of annotators having same skill, having same distribution of tasks, and we actually checked between these two groups what is the difference in the handling time. So as we can see that across all the low resource language and overall, there is a significant decrease in the handling time when it is done through the lean annotation framework compared to the pure manual annotation.
Mm-hmm.
So,
and I see a couple very significant drops in average handling time. Can you point those out?
yes, so we do see a good decrease in handling time for some locales such as Belgium and Portuguese spoken in Brazil, and like Swedish. But the key component here is across all locales, there is a decrease. There is not even a single locale where we see it's almost comparable. Every locale we see a significant decrease. And overall, if we see the aggregated graph, we do see a 40% reduction in handling time.
And in that 40% reduction, did you see any decreases in quality or in accuracy?
No, we didn't notice any decrease in quality. Rather, it decreased the back and forth between the annotator and the reviewer, which actually carved out time for the quality managers to focus more, which increased the overall quality of the data generated.
So to summarize, you decreased average handling time by 40 to 60% with zero loss in quality or accuracy, creating more time for the reviewer in this whole process. I don't see any drawback. Was there any drawback in this system?
There is obviously there are some limitations uh, since we are using a pre-trained large language model. We can't really rely on the judgment of an LLM. So that's what we have framed. It's not like an AI versus human. It's like a human plus AI. So the limitation here is, although it has a very good accuracy across all the modules, it can't be like trusted blindly. It has to be used as an extra intelligence.
Mhm.
I would add to that and say that the human annotators, because this was a very specialty kind of a work, right? Over time, we actually worked in batches of delivery, and basically and we got like good feedback back to the annotators and the quality management team, such that they could retrain and really focus on the languages or locales as well as the PIIs that typically people were getting confused with, right? So that is also something that iteratively we were able to improve. I would also like to say that we were able to achieve very high. So the quality measure here was false positive rate, which we were able to get to less than 5%, actually much less than 5%, and a recall of about better than 90%. And for all the locales, we actually achieved that kind of quality. In fact, much higher than what was required. At the same time, I would also like to say that we are doing a very controlled study here, which is sort of something that we plan to do next is essentially if we vary the noise level, right, in the data. So, I mean, the limitation here is that you're giving a very pure data to the LLM to train on. I would say that there should be some noise such that the LLM actually is able to generalize better as opposed to be training on the pure data, the kind of high quality data that we provided. I think we need to also vary the noise, some impurities in there, such that the LLM is able to generalize. And that would, I would say, downstream, that would be a limitation there, that the data was too pure to begin with. And we are working towards understanding how, if we were to pass data with different noise levels, which is essentially some PIIs are incorrectly marked, how would the fine tuning accuracy change based on that? So that's also, I would say, it's sort of a limitation that we provided too pure data
Mm.
for the training.
Great. And Dr. Abhishek, you'll be presenting these findings in this paper at VLDB in London this year in September. Is there anything that you're looking forward to learning or hearing, or anything that you'd like to observe there at VLDB?
So VLDB is a very premier conference. This is the 51st year of VLDB. As a PhD student, I used to actually publish at VLDB. And one thing is, it's the who's who of data actually go to that conference. A lot of like academic as well as industrial researchers, all the I mean, many of our customers will be there. So really would like to understand and while we present, understand their feedback and what are their use cases that we can actually further help them with. Now, this lean annotation process, we are also applying it across different domains, across different use cases, and across modalities. So this particular modality happens to be text, right? So Harshit is also building a guidelines to instruction following kind of automation, right? That would take in guidelines, and it's going to actually create the technology that will automatically generate the instructions following feedback to the annotators, right? So that is one more next step. But when I talked about the modalities, we want to scale to images, audios, um, video, as well as code as modality. And we've been actually developing a lot of automations or AI assisted annotation technology within Scientific that can help us speed up our delivery with high efficiency and quality of data. As we showed, this was just one example that we showed in a use case where we were able to improve, but we are developing many more across the different modalities. And I'm very confident that Scientific is actually ahead of the curve, providing this kind of expert data as a service, um, to be able to build the next generation LLMs, VLMs, and AI technology. Yeah. So I'm happy and looking forward to the presentation at VLDB.
Great. Wow. With future projects including different domains and different modalities, it sounds like you'll be very busy for the foreseeable future.
That's right.
Well, thanks so much for taking time out of your schedule to join us today and go over the results and the findings in your paper. We really appreciate your time. Thank you.
Thanks, David. Thanks, Harshit, for joining me.
Thanks, David. Thanks, Abhishek.
And thank you to the audience for joining us today in this LinkedIn Live session. If you like what you heard today and you want to learn more, please follow us on LinkedIn. Give a like or a share for this LinkedIn Live to someone that may be interested in what we've discussed today. Thank you so much for joining us, and we'll see you again. Bye for now.